So this is problem 8. Which I think I just labeled, I did label it problem 8. Okay, find the Thevenin equivalent of the circuit below. Find the value of RL that will deliver maximum power. What is that power? Okay, so the maximum power that a circuit can deliver comes from when you have a resistance equal to the Thevenin resistance. So when you are looking for maximum power, you find the Thevenin resistance, and then from that you have this nice formula here that you might want to put on your formula sheet, that P max equals V squared Thevenin over 4R Thevenin. So what this diagram is showing is that we have a circuit, and to the left of A and B, it's some circuit, and we want to simplify it to a Thevenin circuit. And to the right of it is some changeable resistance, and it can be anything. And we're just saying, well, what resistance would it be in order to have maximum power? And so our first goal is to find the Thevenin equivalent of this. And I'm looking at my notes from last year, and they are illegible at best. Okay, so let's start by doing a source transformation of the 32 volt and the 4 ohm. So by this point, y'all should be pretty good at doing the source transformations. So that'll give us a current source and a resistor in parallel. And at this point, we're not interested in anything to the right of A and B. We are just trying to find the Thevenin equivalent of everything else. So this was 4, and this is V equals IR, and 32 equals I times 4, so I equals 8, so this will be an 8 amp current source. And then this is 12, so I have a 4 ohm resistor. By the way, what I'm trying to find right now is V open circuit, because V open circuit is the same as V Thevenin. So I'm trying to find what is the voltage across these two terminals A and B here. So to simplify this 4 ohm resistor and this 12 ohm resistor, I'll do product over sum. So that's 48 over 16, which is 3. So okay, now here's the crazy thing about current sources in parallel. You can add current sources in parallel. So an 8 amp current source and a 2 amp current source, I can just add those and get a 10 amp current source. If they're pointing in the same direction. If they were pointing in opposite directions, I would subtract them. And now I have a current source and a resistor in parallel, and I can use source transformation to change it to a voltage source and resistor in series. Okay, so do I have, well, this was 1 ohm. Do I have any current flowing in this circuit at all?
No, because it's open.
Yeah, it's open. And so I don't have any current flowing at all. And so the voltage across A and B is the same as the voltage across this voltage source. So V open circuit equals V Thevenin equals 30 volts. Because this side, I'll say that's ground. This side will be 30. It'll be 30 all the way across because there's no current flowing. So the difference will be that. Now, from this point, just trying to check my notes to make sure, yeah. No, that was not the year that my arm was broken. It's like my notes are so messy. I was like, is this the year I had a broken arm? And it's not. Okay, so to find the Thevenin equivalent resistance, we make voltage sources shorts and current sources open. We already have this nice setup right here, so I can just short that voltage source. And when I'm doing the resistance, I don't care if there's current flowing or not. I just want to know what the resistance is. So R Thevenin is 4. So we will get maximum power when R load is 4. And that maximum power will be V squared Thevenin over 4R Thevenin. So that would be 30 squared over 4 times 4. Which I have written down as 204.5 watts. So, any questions on that one?
If I do it in the calculator, I get 56.25.
For the last calculation?
Yes.
I do too. Thank you for checking. Good. Okay, any other questions? All right. Did I not record that one?
Could you explain how to get the Norton equivalence of that?
Sure, sure. So if we've already done this, then use Ohm's law to find I. So we'll take our V Thevenin, which is 30, equals I, and that's going to be I Norton. So R Norton equals R Thevenin. And so V Thevenin equals I Norton R Norton, or 30 equals I times R, which was 4. So I equals 30 over 4, which is 7.5. So our Norton equivalent circuit looks like this. So that's the Norton equivalent circuit. Is that okay?
Yeah, it makes sense. Thank you.
Okay.